Okay, so welcome to Module 1. We start with the introduction to APIs, right? So this is going to be a very short lecture. The major point of this week would depend on you watching the YouTube video link that I'm going to attach in the document, right? Later on in the ending part of the video, right? Because that video practically covers everything we need to know about APIs, right? But let's go through the slides. Okay, so have you ever wondered how Facebook automatically displays your Instagram posts? Now, if you didn't know, Facebook acquired Instagram, I think 2011, something like that. So now you have a feature where when you post your Instagram um, photo in your Instagram account, you can have an option to sync it up so that it would also post in Facebook at the same time, right? So if you ever wondered how that happened, that's made possible by an API between the two applications. Okay. Also, how do cloud-based drives sync your files between your laptop, your phone, and your tablet, right? For example, if you are working on a Google document, you work on it through your phone, and then it automatically saves whatever progress you have. When you log into your laptop, you work on the same document, it's already updated, okay? Or if it's in your storage areas, you upload something from your phone, you upload it in your drive, it's automatically reflected on the desktop application version of your drive, right? So that's also possible using an API. Also, um, this we touched on this when we were discussing legacy systems in systems analysis and design, right? So if you don't remember, legacy systems are very old systems written in old languages that most companies still use because they have important data there, right? So if you want to interface your legacy systems to work with newer types of technology written in another programming language, you have an API to do that, right? So what is an API? So an API is application programming interfaces. Okay, so that's API. So APIs in 2013, over 10,000 APIs were published by companies for public consumption, 4 times more than 2010. These are mostly web-based APIs. All right, so during this time, when we say API, mostly they pertain to web APIs, but it's not always the case. Okay, so we're going to discuss other types of APIs. Okay, when we say API, we mostly talk about servers as well because most APIs are server based. So they reside on your server side. Okay, so the API talk often involves servers where you as a software developer, you write code and you implement this code in your server. And what your server does is continually run this code in order to cater to requests from clients, right? So that's basically what your API does as well. Okay, so you write an API in order for you to have something that bridges your back end to the client side so that you have your client side don't really need to write any code anymore. They just request a call through the API and the API does the job for them. The API gets requests and sends back data or does specific functions based on the nature of the API and sends it back to the client. Okay, so it's a client server interaction, right? So here we also consider programming and development paradigms because like we said, like you probably know already, in the current industry there are many programming languages, there are many software development methodologies used, and sometimes one system is written in another language or developed a certain way, and you want to integrate that with another system or another functionality that you want. And how do you do that? Now, it's really hard if they're written in different languages, right? So you can't just query whatever you want from the other system. So that's where API comes in. No? So no matter how diverse the programming and development paradigms are, your APIs actually bridge those different systems together, right? So that's the main purpose of the API. Now, as long as the input is valid to the API and the output is valid from the API, these two systems, which were seemingly incompatible, can now be integrated. Can now send data to and from each other, right? So another example is what you commonly see in mobile applications. So if you've been developing mobile applications, and for example, you want to integrate um, the Google Maps feature, no, you don't really need to code anything in order for you to use Google Maps. It's already there. It's available for you to use. You just have to get the Google Maps API and sync that with your application. No? Another is most of the capstone and thesis projects of your third years. No? So usually we want them to have some sort of virtual reality or facial recognition or something like that. No? For IT students that don't really have AI subjects, you can use APIs for that, right? So even if you don't know how to train a model to do facial recognition, you can have your application have the same feature by getting a facial recognition API and integrating that to your mobile app. Okay, so something like that. All right, so yeah, automation and integration. APIs make mostly website data, but not always, digestible for a computer. So it automates works for computers and also for us as developers. Okay. Key point is you don't need to write anything if you don't know, if you have an API that already does that function for you. No, you can just link that API. So here is a general example of what it looks like when a client and a server communicates through an API. So your applications here, your wearables, your desktops, phones, um, gets and sends data to and from a certain server backend through the API. Right? So you can post, get, put, delete, and custom queries, custom functionalities, as long as the API allows you to do it. Right? So how do APIs work? Right? APIs work via normal client-server interaction, like we already discussed. Although most APIs reside on the server side, it bridges the server and the client side. Right? So your client requests some service from your backend, provides an input data in order for that request to be valid. Your server validates if the data is authenticated, or if it's valid, or if it went through the proper transfer protocol. If it's approved, you send the request back to your client side. Right? So that's the normal workings of an API. It doesn't really matter what technology or programming language is used if the input data and the output data to and from the API are of the same format. This is what I've been talking about earlier. So integration comes into play as the API bridges between the client side and the server side. So you have an example here of a working infrastructure of, for example, a company. Okay, so you have different applications and systems here: Webinar, Asana. You have webpage, Stripe, Bizible, yeah, Salesforce, which is a famous cloud-based enterprise resource system, right? So for leads. So you can see in this infrastructure that these are different applications or systems, right? And if you have an API that the input type and data format and output type and data format is known to all of these systems, to this API, you can use this API to bridge all of those. Okay? So you can now send data to and from all of these systems. Now this really works in handy because like in my example earlier, you can't naturally integrate a Salesforce module with a webinar module, for example, right? But if Salesforce has an API for a certain functionality that can be synced with webinar, and webinar knows that format, you can use the API to bridge the two. Okay, so that's mainly the use of APIs or how they work, right? So another example here, Microsoft Azure is a famous cloud computing platform today. No? You can use it to create apps, test apps, run cloud-based apps, and all of that. Right? They have an update tracking API. So as you can see, API can be tied to the specific functions that they can do. Okay? So Microsoft Azure has update tracking API. So they made this for mobile apps that are created in the Microsoft Azure that are downloaded on mobile phones but haven't been online and synced for a while. They made this API for it to get easier updates. Okay, so doesn't matter if you have 6 months not online and not synced. Once you go online, it's going to use this API to get updates from the server. So here, this is a walkthrough of that. So you have here the mobile app that goes through the API and wants to sync with the server, right? So the sync request is sent and the server acknowledges that it receives the request, but it's the first time that he does that. So gives the data, if it's authenticated, he gives the data and the latest version and a sync response to the mobile app using the API, right? And then the mobile app now keeps this version here, version ID for future use, right? So after a while, when the mobile app is offline and then it finally goes online again, it accesses the API again, update tracking API, and it already has this version control. Okay? So it just sends it to the server and it recognizes the changes, the instance that this version ID 123 has, and so it provides all of the updated things to the mobile app. Okay, and also has a new version number. Okay, so that interaction is made possible by this update tracking API that Microsoft Azure has. Okay, without that, the mobile app will have no way or would have a difficult time accessing the server, okay, for updates. Okay. All right. So another example here is, for example, you have a legacy system containing pertinent data synced with newer devices and clients through an API. Because, like we said, legacy systems are outdated systems, so they don't really have this natural way of connecting with newer technology, right? So in order for you to still use your legacy systems with your newer technology systems and clients and devices, you need to have an API in between. Okay, so this is an example. A legacy system exposes a file transfer protocol interface to add orders, and then you have this wrapper that exposes the protocol interface as a SOAP service or an API service. Okay, and then the API consumer consumes this service in order for the data to be sent to the legacy system. So nakita nyo, so this is a bridge. Okay, this is a newer format device and client. It requests something from the legacy system. The API makes sure that the legacy system has receives this message, right? And then the API then sends a response back to this client here that the message has been sent to the legacy system. Okay, so it's a very simple example of how APIs work, right? Right. So as you can see, um, APIs have a set of routines, follow certain protocols and tools for building and integrating software applications. So para siyang, it's like a detachable um, access door. You know? So your once encapsulated module or system can now be accessible to others using the API. Okay? So it expresses a software component in terms of its operations, inputs, outputs, and underlying types. Okay? So the underlying types here usually just concerns the input and output, okay, of the data. Because as long as that is valid, your API is good to go. Okay. For example, if you're syncing, if you have a website and you want to sync it to Spotify, and you connect the Spotify API to your website, you don't really need to write the code for playing the music and getting the playlist in Spotify, in your Spotify account. Now, the Spotify API already does that for you. So you abstract from that. You just want the functionality, you just connect to the API. Okay? So defines functionalities independent of their respective implementations, allowing definitions and implementations to vary without compromising the interface. So yun din. You can work on updates on the different sides of your clients and your servers without affecting the API. Okay, so it's independent of on its implementation. Okay, now most APIs come in a library that includes specifications of how to use them. Right, via routines or method calls, data structures, object classes, and variables. Now, if you remember your programming language introduction to programming subject, when you talked about methods, right? So it's like um, a higher level of abstraction from your methods, because you write a method, you have valid inputs for the method. Once those inputs are valid, you can now go to the method body and execute whatever the method does, and then sends back whatever the method returns, right? So if you think of it that way, APIs are the same. No? APIs are the interfaces or the input parameters in your methods. Okay? So as long as um, you know the proper input, you can access it through the API, and once you get through, you can access the other side already, be it the client or the server. Okay? So yeah, in other cases, there are just specifications of remote calls exposed to API consumers, parang yung example natin with the legacy system earlier, like SOAP and REST, which we'll discuss at the later part of the course. API specification can take many forms, but have standards. Okay, like Microsoft Windows API is a standard. Programming language APIs like Java APIs. C++ also has APIs like standard template library. Python also has its own APIs. No, sometimes nga, people um, nito, synonymously talk about methods and packages and subroutines as APIs, because yeah, the level of abstraction is um, actually the same. No, mas higher level lang yung APIs. Okay, so there are many APIs for many different functionalities to integrate into any system. So like the example that I gave earlier, no, if you have a mobile app and you want to have different functionalities, you want to integrate into that system, but you don't know how to write it or code it, you can just look for an API that does it for you, and then you sync that API into your app. Okay, so this is what you're going to study in your final project for the course. Now, for example, you have augmented reality APIs, virtual reality APIs, speech recognition APIs, face recognition, social media APIs, and a lot more APIs. Custom APIs are for internal use, like our example with the legacy systems. Okay, usual channels that APIs work on are your websites, your mobile apps, wearables like your smartwatch, and then custom systems like your legacy systems. Okay, all right. So for your project, I'd like you to come up with a group with groups of five. In groups of five, search for an API that interests you. Okay? So, madami dyan. No? So, augmented reality, marami. You have social media, you have Twitter API, you have the Facebook API, YouTube API, any functionality that can be integrated into any system. So you can research, and once you find an interesting API you want to study and evaluate as your final project, you can write your group member's name on the link in the document I'm going to send later, and your topic. Now this is first come first serve. No, we have 6 sections. That's a lot. Um, for 5 members each. I don't want any APIs to be the same as a topic. Okay, so first come first serve. The first ones to write their API topics on the Google Sheet gets that topic reserved. Okay, so just fill that out once you decide on your group mates and your topics. Right. So that's it. It's a very short lecture. I'd like to end with this. I guess my students in the morning class in AI already saw this, but anyway, so we're full online this term, right? And I'd like just to end with something, a reminder. No? We give you all of the academic resources that we, our instructors, we try to deliver our courses the best way we can, right? So we give you all the academic resources, and then you couple that with your learning habits, and once that's successful, that's the only time you gain actual knowledge, as in learning. Okay, because I've been seeing many posts in social media complaining about stuff, but uh, we're just trying to do our jobs and do our best in delivering all of these courses to you full online. No? So the learning part actually is more dependent on you guys, okay? On your learning habits, how you consume these academic resources that we give, to transform that into actual knowledge that you can use in the future. Now, if you choose not to learn from our efforts, and then that's on you, right? So we're all just trying to make the best out of our current situations right now. No? So there are, of course, there are faults, but yeah, we're just doing our jobs. So just a reminder, okay? So if you don't want your tuition fee to go to waste, might as well do your part, because I'm doing my part teaching here, okay? Now, supplemental learning materials will be sent in a separate folder or file containing a link that I already stated on our course content video. It's very informative. It actually discusses everything you need to know about APIs, and the link to the Google spreadsheets to fill your groups and topics for your final project. Also, I have an essay question on that document. I'm pretty curious of your answers, what your answers are going to be there, because yeah, so as we discussed, APIs can be anything. Now, it can be functionality that you want to integrate. It can be a bridge to an entirely new system, to bridge two systems, something like that. So I'm curious as to what, if you were to create an API, what functionality would it have? No, so so that's your essay question. I'm really excited to read your answers there. Okay, so that's it for module 1. Be sure to be online next week on the stated schedules per section, so that I can check your attendance. And I'm going to upload module 2 next week. So I don't know if I already said this, but once you're done with your essays, hold on to them. We're going to upload that once your Canvas LMS becomes available. Okay? All right. So that's it. Bye, guys.